This will be about the effect of interlens distance on fusional limit in stereoscopic vision using a simple smartphone head-mounted display. Mr. Hiroyuki Morikawa will speak. Mr. Morikawa is an assistant professor in the Department of Integrated Information Technology at the Aoyama Gakuin University in Japan.
Thank you, Chairperson, for introduce. I'd like to give a presentation that titled Effecting of Interlens Distance on Fusional Limit in Stereoscopic Vision using a simple smartphone head-mounted display. The simple head-mounted display is attracting attention. The HMD uses the smartphone as a display and it's made of a low-cost material such as cardboard. One of the most famous examples is Google Cardboard. Unfortunately, I can't find the common name of that HMD of this type. Accordingly, I refer to this HMD as simple HMD in this study. This simple HMD is convenient for viewing 360-degree movies or VR content. Moreover, such HMDs can display stereoscopic images by showing images for left and right eyes separately. Since they can be manufactured at a low price, there are many HMD of various designs in market. In addition, the smartphone that is used in the HMD is also diverse. The viewing environment of stereoscopic images changed depending on the combination of these elements. Regarding binocular vision, differences in the viewing environments might cause eye fatigue and visually induced motion sickness. Therefore, effect of difference of HMD design must be examined from the point of view of safety. In this study, we considered that what element of simple HMD affects the viewing of stereoscopic image. There are several elements of design of a simple HMD that might affect for the stereoscopic vision. These elements contain as follows: interlens distance, interpupillary distance, hereafter is called IPD, optical materials. This means mainly lens quality such as aberration or distortion, and display size of a smartphone. In this study, we focused on interlens distance and IPD and examined the effect of these elements for stereoscopic vision. I'd like to explain how does the change of interlens distance affect the stereoscopic viewing. The display of a smartphone was put on near eyes. Thus, it is difficult to focus on the display because the focal length is too short. Therefore, the lens is used to magnify the display and to extend the focal length. The image of display is observed as virtual image. The stereoscopic image is represented by viewing the virtual image from both left and right eye. When the image of display is magnified, the center of magnification is the axis of lens. Then, the interlens distance changes, the center of the image magnification also changed. The shift of image by magnification is rather than the shift of center point. As a result, the disparity of stereoscopic image is changed even if the same image is shown on the same display. In this slide, I'll explain about experimental condition. We designed 3 HMD conditions by interlens distance and a control condition by using 3D liquid crystal display. The HMD used for the experiment was prepared using the Google Cardboard template available from Google. The lens mount was adjusted and 3 HMD were prepared with interlens distances of 57.5, 60.0, and 62.5 millimeter as experimental conditions. We also prepared the control condition using 3D liquid crystal display. The display was used 23-inch passive 3D display. Polarized glasses were used to view the stereoscopic image with this display. The viewing distance was set to 370 millimeter in order that the angle of view is equalized with HMD conditions. As HMD conditions, a smartphone weight of 5-inch display was used as the display. A virtual image was viewed at 360 millimeter using the lens with a 45 millimeter focal length. As a stimulus, a random dot segment was used. The stimulus image consisted of a background and the target. The visual target as a circle without an outline. Okay. Okay. Okay.
There we go.
Sorry. Yeah. To determine the fusion, the visual target was designed such that the circle could only be perceived when the target image were fused. The disparity of visual target was controlled by moving the circle to left or right. In addition, to avoid the vertical disparity occurring by rotation of smartphone, white horizontal lines were placed at the top and bottom of the target. To evaluate the effect of the difference of interlens distance, the fusional limit was measured corresponding to the difference of interlens distance with the up and down method. The participants viewed the target with continuously changing disparity. The participants indicate when they judged that the image was fused and when the image was not. They first viewed the stimulus with increasing disparity. Upon indicated that the images were fused, the disparity was then decreased until they indicated that the image was no longer fused. The disparity was increased and decreased alternately 6 times. And the average of the reported disparity in last 4 trials was calculated as a result. The far and near fusional limits were measured independently. I show summary of procedures. The participants provide informed consent to participants in the experiment. Subsequently, the stereoscopic vision function was tested and confirmed to be normal. Each participant's IPD was also measured. The participants practiced the measurements using the up and down method prior to experiment. Following the measurements of the far and near fusional limit under the control condition using a liquid crystal display, both fusional limits were measured under the 3 HMD conditions. Combining the 4 conditions, 2 fusional limits, and 6 trials, the measurement was repeated 48 times in total. There were 19 participants and average age was 21.6 years. However, the results from 70 participants were available. This figure shows the environment of experiment. When the participants viewed the image through the HMD, their chins were fixed on the chin rest, and they were not allowed to move the HMD. The position of the head was also fixed the control condition using the same chin rest. To prevent the HMD from tilting, its housing was fixed by the participant with both hands. The stimulus image was presented by sending the image to the smartphone wirelessly from a PC. The experimenter controls the disparity. I'd like to show the result. This figure shows the average of the both fusional limits as a disparity angle regarding the control conditions and three HMD conditions. Negative value means the parallax of near direction, and also positive value means the parallax of far direction. The blue line indicates the far fusional limit, and the red line also indicates near one. At the HMD condition, the fusional limit generally tended to shift to cross direction. Furthermore, the tendency, the tendency was stronger or at near fusional limit than far. Therefore, to examine the interaction between the viewer's IPD and internet distance, we examine the results that focus on the difference between the IPD and the internet distance. Participants were divided into groups. Participants whose difference was plus minus 2.0 meter or less were categorized into the small differential group under the 60.0 and 62.5 millimeter conditions. The remaining participants were categorized into the large differential group. Under the 57.5 millimeter conditions, this difference value was set 5.0 meter in order to make equal the sample size with other conditions. In these figures, the vertical axis indicates the difference of fusional limit of control condition as a disparity angle. The small differential group shows the smaller difference of a fusional limit than the larger difference group. However, the tendency was reversed under the 62.5 millimeter condition, whereas the change in the small difference group was larger. Now, I'll summarize the results and give considerations. The results of experiment shows that the far and near fusional limit tended to be close in HMD condition. These results suggested that the simple HMD make easier to view the near parallax image. However, the meaning that make easier to view the near parallax is to say, in other words, make harder to view the far parallax. These results are not always positive from the perspective of image safety. Moreover, we consider that why the fusional limits were changed to near. One possibility is that there might be a psychological effect of viewer trying to see an image that is close to the viewer, because both the lens and the housing itself are close to the eye. As a result, the changes in fusional limit from that of control conditions was smaller in the small difference of IPD and internet distance. This result suggested that the small difference between IPD and internet distance might provide a viewing environment that is similar to the normal 3D display. At the last, I will summarize the knowledge from this study of image safety. A simple HMD make easy to see near parallax. Therefore, the fatigue might be caused by viewing the image that contains extremely negative parallax. Moreover, the interlens distance is difficult to adjust because many products fix these lenses. Thus, it is important to support the various IPD when designing these simple HMD. Okay. I'd like to make a conclusion. In this study, we examined the effect of the interlens distance when viewing stereoscopic image through a simple HMD. As a result, from experiment, we could obtain the knowledge as follows. When the viewing stereoscopic image using simple HMD, the far and near fusional limit tended to be close. Furthermore, the effect was smaller when the difference between IPD and interlens distance was small. As the future tasks, we'll continue to investigate the effect by other factors of design. Thank you for your kind attention.